Okay, so welcome to the Multivariable Calculus course on 2021. My name is Hyo-Sang Kang, your instructor for this semester, and we are going to have lots of fun this semester because the course will not be only lecture, but we'll have lots of activities regarding your project. So let's begin with our syllabus. Here's our syllabus. The screen that you're seeing is the Notion page that I'm running. So you have a little slight lagging here. This is the same page that I uploaded on the course description on our school website. So here's my information. My office is the E7 building, G11. And my email address is here. You can also contact me through any other type of medium, such as messengers or the phone number, but I'm not going to make it public here. If you want to, just ask me. And our course is about learning the multivariable functions. So basically, multivariable calculus is about the multivariable function and its properties on differentiation and integration. And meanwhile, at the time when I wrote this syllabus, I didn't aim for the project-based learning, but during the vacation period, I applied this class as a project or problem-based learning, and the school accepted it, and then I will going to run this course as a problem or project-based learning class. So that means it's not just going to be a lecture, but it's going to be the project, your own project that involves this course. And one more thing. So in the previous semester in the differential equations and applied calculus course, you probably learned MATLAB as a programming language. I'm going to use Go. It's the name of program is Go, G-O, as a programming language for this course. Of course, the MATLAB is very easy to use and very powerful, but Go is more useful when you really want to solve a real problem. Well, MATLAB is also some way useful, but there are several reasons why I use Go. I will explain that later. Okay, so you can read the course objective, and I want to emphasize our textbook is the following book. It's look like this, and you can buy online through any bookstore shop. This is very nice book, and you can see that this is also official textbook used in DGIST. It has lots of material, but I'm not going to cover all of it. However, I advise you to read carefully on every subject, especially the subject is related to your project. And the grading. So this is a funny cartoon about the grading, and I found it on the web. So the grading component, let's jump into the grading component. So in-class activity counts 40% of your grade, programming assignment is 30%, and report assignment is 30%. You will notice that there is no midterm and final, but however, there is one. So in-class activity, I will explain later about what this means. But basically, it it's about asking questions in classroom and self-asking and self-answering activities, okay? And you need to stack certain amount of number of questions and answers in order to get the full score on this portion. However, if you couldn't, then you can choose to take a midterm or final exam on the midterm and final week. So that counts for 40%. And about programming assignment, as I mentioned, you're going to learn Go, and I will teach you how to use Go language step by step. And if you simply follow my instruction, you will not get a penalty on this portion. But you have to do this continuously, not put it away until the end of semester and do that all in the end of the semester. That's not gonna give you the full marks on this portion. And about report assignment is that you're going to set your own problem to solve or own subject or project. And you're going to write about how you set up your problem and how you manage to organize the strategy of solving that problem. And if you actually did solve the problem or project, then explain how you did it and what was the result and what's the expectation of your outcome, and so on. That counts 30% of your grade. So this is a Go code about your letter grade. Basically, it means that if you have higher than 90 points, then you get an A+. You have a higher than 80 point or equal to 80 point, then you get A, and so on. So you can read this code and find out by yourself what was the actual grading scheme. All right, so here's a weekly schedule. So we have basically covered entire material that usually the multivariable calculus course covers. However, I want to emphasize key questions in each week, and these key questions is followed by many other questions, sub-questions, and maybe some unrelated question, but if it's necessary to solve your project, then I will cover that questions too. All right, that's all of our syllabus, and I want to move on to our course page. So we have an LMS page, and I'm going to use LMS for notice and the putting your individual grades, but I'm not going to use that as uploading file things and so on. So almost every time you'll just need to visit this page, the Notion page that I send you the link in the email. So you can read the instruction that I wrote. I'm going to explain briefly how this works. So here's the red page that called the template for the student page. So you're going to write whatever assignment that I wrote in this template into your page. Okay, so in the beginning, I assigned several assignments here. So one is questions. In the question table, we have a new page called the multivariable functions. And if you click that, then there is two questions that I posed here. One is what is multivariable functions, answer that you have to write on your own. And another question is what do we learn from multivariable calculus? You have to put your answer on the right-hand side here. But whenever you write your answer, please write in full sentence, okay? And make it as long as possible, but not verbosely. Just be concise, but just put it put it in complete sentence with complete contents, okay? So this is our assignment in this question section, and I said that this question counts for in-class activities in your grade. And there's a programming assignment too. So my first Go code is our first assignment that says that task is writing the Go code using these following instructions. So you have to create two files, the main.co and main.exe. And if you're using Linux or Mac, then the main is the name of file, the executable file. And you are expected to run this main.exe, and it should output the string, hello, welcome to BS101. Now, how do I check you actually did that? So you have to put your code into the website, and then you have to embed that website into this Notion page. So that website is called Replit. So Replit is a free website that you can upload your code and run your code. I will explain that later how you use this website. And the next one is the project. So you have to your own project. So I want to ask you fundamental questions of your project. So if you click that, so there's a little bit of lagging here. So I asked, what is the fundamental problem that you want to solve, or fundamental questions? So the question that you think it's very important for you and it's very critical to solve in your own perspective. So I want you to find the problem that is important to you, not important to others. So for example, if you want, if you say, I want to major in mechanical engineering, I have a problem that I want to help people who in disabilities, and I want to make this device that helps people to move. So you have to elaborate what device means and what kind of function that this device has. That's the problem that you actually, that's your own problem. That's the good problem. But don't set the problem as, I want to solve this kind of formula and I want to solve this kind of questions which is in the back of the book. And that's not interesting questions. That's already solved already, right? And then nobody cares whether you solved it or not. So write your own questions and write your own problem that matters to you. And also consider that problem carefully, and why solving that problem is important to others, okay? Because that's what matters when you do the research or applying for a job, that what you do is important just only because it affects other people's life, right? So I want to emphasize that one too. And also we are learning about multivariable functions. So please consider how you're going to use multivariable function to solve this kind of problem. Okay? So write your answer here. And you see the final report, I already made it as a empty page. So the title is just a temporary title. You can use your own title of your project report and write freely on this page how you express your report. So some of you are not familiar with this Notion page, Notion website. So I'm going to show you how to use it later. I'm just going through the briefly going through what it looks like here. So extra means that you can use anything on down below. You can put anything on down below. I'm not going to care about what's on these extras. However, don't change this question tab, the programming heading and project heading and the contents of this, the name of these tables. So this is the initial page I already made up for you, but during the class progress, I'm going to, sorry, let's go back to here. I'm going to upload new assignment to this red page, okay, to this red page. So you're going to see the difference between the previous page and the current page, and you have to copy or copy and paste these newly added pages to your own page and then write your answer to your own page. You're not writing your answer to this template. You're just copying from the template and then write it on your own page. Okay. So let me. These pages are made for only visible to these persons, each persons. So you see that if you click on this one, this is me, and this is our teaching assistant who's here, sitting here. Say hello. And you see, I invited you these pages through the DGIST email. You have to make your account using the same email, okay? And then once you do this, you can see that on your left menu here, like here, you will see the pages that I shared with you, okay? And also, this page, this page itself is visible to anyone, so it's public here. So you can access this page anytime, but you cannot edit it. But the individual page, you can view it, only you can view, and only you can edit. Of course, I can edit, but I'm not going to edit. So don't change all of these properties. Don't check this, because this is for my personal uses here. So I'm going to use this for checking someone who actually did well on some of the assignment, and I will introduce that in the class. So don't check any check marks here. All right, so and these are all student pages. If you're going to drop, I'm going to erase that. So here is a weekly material that I'm going to update time to time. So in the week 1, we're going to have orientation, and I'm going to introduce what programming language Go is. And also I'm going to explain what multivariable functions and overlook what this course is about. All right, so you probably have also many questions because you don't know how to use notions yet, or you don't know how to use programming language Go, or you don't know how to find project problems. I will going to do that with you for the first few lectures, so don't worry about that. If you have any question now about this course, please ask. No questions? Yes, you have to write your whole project report in English. As I mentioned, it's not hard. Just if you write your sentence perfectly in Korean, Google Translate really do the great job. Good questions. So thank you for asking question in English too. Okay, so question is, can I answer anything other than multivariable calculus on these 3 questions in the page fundamentals? Yes, that's a very good question. You can ask your own questions, extras, and that actually will count. If you answered perfectly, then it will count as an extra points too. So if you meet all the requirements, then you probably don't need to do the test, taking a midterm test or final test. But sometimes people cannot answer the required questions properly, so they probably miss some points. So in that case, you can ask extra questions on your own and then make up those lost points. Okay, I also want to say about the class participation. It's free. I mean, you can choose whether you want to join online or offline. But if you're willing to come offline, I can show you how classroom looks like. So you can see through the small webcam on the bottom right. So this is a classroom usually which can take up to 40 students. But because of this corona situations, we probably have maximum of 20 students in this classroom. So if more than 20 students willing to come, then it should be on the first come, first serve basis. All right. So where should we begin? Let's start with our questions. This is syllabus, sorry. Oh. Hang on. All right, so let's begin with well, let's begin with week 1 material here. I think it's freezed here. Okay, here. All right, we went through the course syllabus. If you have any questions, please ask anytime through voice, or you can leave a text. So what do we learn from this course? It will basically answer the questions in the questions table in assignment. So let's start with our title of this course. So I want to know what multivariable calculus is about. So think about what this multivariable means. So it says multivariable. It means there are many variables. So by definition, many means it's the opposite of single. So it says you have two or more variable in the functions. So it's about a function, or functions with two or more variables. And what's about calculus? So usually when you say about calculus, it's about differentiation and integration and properties regarding that concepts. Integration and differentiation. So here's our answer. Multivariable calculus is about integration and differentiation of a multivariable function. And what is multivariable function? So, as I mentioned, it's about a function with two or more variables, but usually when you say a single variable function, it's written as y equals to f of x, right? Y and x are also variables. We have two variables. Why we don't call it a multivariable function? Well, so you have to elaborate this definition further. So y equals to f of x is called a single variable function. So multivariable means that not only just we have two or more variables in the independent variable and dependent variable, but also in each independent side and dependent side, there are number of variables are more than one. So multivariable function means that we have two or more independent variable or two or more dependent variable. So you see, we have a function called name f, and this f, x and y serves as independent variable that determines the dependent variable z. So for example, z equals to x squared plus y squared is an example. So in order to find the value z, we need to know the value of x and y, which are independent in choosing this number of x and y, and the formula of z is given as follows. So how about this one? We have two dependent variable and one independent variable. So for example, I can set this ct equals to cosine t and sine t. These two independent variables are dependent. These two dependent variables, x and y, maybe you can call it x and y, is dependent on single independent variable t. Okay, so these are also this is also multivariable function. So that answers two questions. You can write it in your full sentence in your own. And briefly, let's go through what we're going to learn in this course. So it has been 7th year teaching this multivariable calculus in DGIST, and I have also lots of years teaching this course in other institute. So in this moment that I kind of know the full material in my head, what's going to happen in this semester. So for example, this class will divide it into two big parts. The first part will count about the differentiation, and the second part counts They will teach about the integration. So in the differentiation of multivariable function, we will begin with the differentiation of single variable functions and how to generalize that. Before that, we need a notion of partial derivative, and that involves the limit of multivariable function. And once you know the partial derivative, now you can think about the differentiability of multivariable functions. That involves some linear transformation, which is the matrix. So definition is not hard, but what hard is about the application of this differentiation. So we're going to use this concept of differentiation to find approximation of function or finding extremals and so on. Okay? So this is the first part of our lecture, and the second part is about the integration. Now you're going to integrate multivariable functions. That means you're not having area as integration. So now we have a different situation. So first of all, in the integration, we're going to talk about double or multiple integral. And once we define what that is, we're going to talk about line or surface integral. And once we know these concepts, then we have to talk about the vector fields. And if you understand perfectly about this concept, then now we are ready to talk about the Stokes theorem. Or Gauss theorem, which is called divergence theorem. And meanwhile, as I mentioned, the vector field, we're going to talk about concepts of vectors. Actually, before we talk about the differentiation and integration, we have to talk about what the multivariable functions are. So we have to talk about the vectors somewhere here. Okay. So let's go back to our keywords. So let me mention a few things about class participation. So how to ask questions. So if you read carefully again about the first project, I asked a question based on three words. One is what, the other is why, and the last one is how. So what, why, how is the words that you have to start with whenever you ask questions. So for example, I want to know what is multivariable functions. So the question is about what, and I want to know why we have to study multivariable function. So there's no answer to that, but you can find your own answer. And the third one is most interesting one. How do you understand multivariable functions? That's the entire content that we are going to cover in this course. So keep in mind what, why, and how is the three keywords that you have to start with whenever you ask questions. And midterm and final. So I mentioned that if you want to make up your class participation portion of your grade, then you can take, it's up to you whether or not take a midterm or final. But keep in mind that midterm and final are not in the format of solving equations and finding values or calculating things. I will going to put questions on what we covered in principles, and you have to explain in full sentences, or you have to write in full sentences about the questions that I wrote in the midterm and final exam. Okay, so let me mention about the project. Why you should have a critical mind. Critical mind means that you have to think critically about everything here. So I had a chance to talk with freshmen in last semester, and I asked two questions. What is the problem that you want to solve? And second one is, first one is why did you come to the DGIST? And second question is, what is your problem to solve? So I personally think that if you have one question, one complete question that you believe it's really important to you to solve after these 4 years of study, then you had a successful university life. It's very hard to have such questions, or just single question. So you have to build up your question from now on, from now. So it's not about your major, not about your career. It's the fundamental question that matters your life. Okay. So for example, maybe you enjoy playing game. Then it could be the problem is about game. You're making game, or playing well in game, or analyzing game, or building games, whatever. So think about why it's important to others and why is it important to you. So let me mention about how to manage your project. So good way to manage your project is keep thinking about your project. And when you have a new idea, write it down. So if you have personal diaries or personal page, then you write it there. But if the best thing is you just use the Notion page of this course as your scribble page. Just write it down everything, and then put it nicely afterwards. Okay, so do it constantly. Don't do it at the end of the semester. Just think about the question now, and then move on to the next step. All right, so let me mention about the programming language Go. Why Go? So I used MATLAB, and probably other sections also use MATLAB. Why not using MATLAB but Go? So MATLAB is very powerful. It has lots of tools and lots of pre-existing packages. But it's sometimes too nice, too well-packed that you cannot change inside what's going on. So Go is more primitive. So you have to even write your own code to sort out these arrays. Go doesn't provide the basic packages, not many basic packages, but people are writing Go codes that if they need something, then they publish it to the GitHub site, and then you can download and use it. And there are many packages that are available to other programming language, then it's available to Go packages too. And that's not the reason why I use Go. So Go is very intuitive language. I used C, Python, MATLAB, and so far Go is the best language that I can learn quickly, and I can read other people's code quickly. So how to learn Go? So just Google Go. Go here. Sorry, it's lagging here because I'm recording and the streaming same time. Here we have Go programming language. The golang.org is the official Golang distributing page, and you can download Go here, and also you can let me here. You can work any Go code in the playground, and if you click Documents, there's a tutorial how to install Go and how to get started. So this one is good. This one is good. Good place to start. What is this? Okay. And also the tour of Go. This is the step-by-step guide to learn Go language. So I suggest you to follow this instruction at once and then move on to the next step. So this is very useful. So if you know some pre-knowledge on programming, then Go could be a very nice language to learn, but I know that most of you have no experience on programming languages, so I will do step-by-step instructions on Go, and if you simply follow my instruction and typing exactly the same thing that I show you, then I'm not going to make any penalty on programming portion of the grade, okay? Just follow my instructions. But if you do more, if you want to do more, then it's great. You can put it into the project and to get an extra, or you can put it into maybe question sections and you can get more extra points. All right, so that's the Go language. What I do teach and not teach on Go. So I'm not expert on Go or expert or programming language. I'm just, if you put it analogy of driving a car is like writing a programming code. I'm just a driver, regular driver, normal driver that drives in the regular city roads. Experts like professors in computer science are Formula One driver. I'm not teaching how to drive a Formula One car. Okay? I'm just teaching you how to drive a regular car, normal car, with just not violating the rules. Okay, don't expect too much on me, but I can probably assist you how to accomplish your task if you are first time using this programming language Go. All right, so about Go, how to install Go. I show you the page, the official Go page, and in the main page, you just download it and then execute the downloaded file, then that installs Go. However, now, installing Go doesn't mean that you can write your Go code right away, because you need some tool to help you to write in Go code. That's called the programming tools. You can search with the IDE. There are many programming IDEs. One that I use frequently is the VS Code. Just Google VS Code. It's called Visual Studio Code. It's free, and it's not only covers Go programming language. It covers the entire programming language. There are lots of extensions, and also a great extension for GitHub function. This is great. So download for Windows and then install it on your computer. Other IDE that I recommend is Golang. not Golang, it's a Goland, okay? It's not, basically it's not a free IDE, but I think if you enroll your account as student account, I think you can use it for 1 year free. This is actually specialized to Go programming, so it's very nice IDE. I actually often use this one instead of Visual Studio Code, but in this course I'm going to use Visual Studio Code mainly. So other method of using Go is a little bit of tricky, a little bit cheating, but so using Replit, Replit, not Repli, Replit. You don't have to install Go. It's just a web-based coding scheme. So you're using cloud computer to run your Go code. I already logged in and made an account, so I have this page, but you might have a different page. Just log in, and then let's say I want to make a new Replit, or we call the REPL or something like that. So I choose a language and name it anything. Just it's a random name that they choose for me, and create REPL. And now this is the web-based coding IDE. So they give the basic Go code. You can start off with the empty page, but this is the basic. It's the basic the format of Go code. So files is main.go that you're looking at is main.go, and we have a package main is called, and then you import the basic package called fmt, and then function main is the function that called when you execute your Go file, and fmt.println and hello world. And either you can go run main.go, or you can build your Go code to create your executable files. So for example, go build everything means that now we have, so maybe I have to refresh. Go build. They should have main.exe here, but they don't have here. Okay, so they have in here, and when I put ls command, they have main right here. That's an executable file. So if you run this in the window, then it will be main.exe, but this is the Linux, the cloud computer is a Linux-based computer, so we have just main. So main is the executable file here. So I'm going to run this main here. Then they have the same message. The message comes from this function, so hello world. So if you want to change this to welcome BS101, I forgot what was the task. The task says issued so in this task, my first Go code requires me to put welcome, hello, welcome to BS101, right? So then in the Replit, okay, so hello, welcome to BS101. And then again, so I changed the Go code, then either I run this Go code directly from this source file, or I have to build again because this main executable file is compiled with the previous version of Go code. So if I simply run this main again, that prints the previous message. So I have to build Go again. And then now it reflects the changed string here. So this is the easy way to access to Go without installing Go on your local computer. Now let's copy here, or maybe there's a share page, or maybe just copying is enough. So I said that you have to put your Replit code into the result so that I can grade your assignment. How you do is the following. So this is template page, so I'm not going to edit here. I'm going to make a dummy student here, dummy, and open, and so here's pages. Programming, okay. So you don't have to put your main.go file content or main.exe file into the Notion page. What you have to do is simply put a Replit here. So this is a new feature in the Notion website that it can embed a Replit page. So just /Replit pops this Replit embeddings here. So click it, and then paste the Replit website page, web address. So that's the address of Replit REPL, the previous REPL in the Replit. Okay, so embed a REPL. So wait a few seconds. Then I have exactly the same thing in this Notion page. Okay. So what's good about this page is that you can even edit your REPL here. Okay. So for example, I can put a exclamation point here, and then I want to run this again. Go run main.go. Then it does the running, okay? So do this for every assignment, and then I can see how you've done this well. And you can edit on the fly on Notion page of your assignment. So it's completely free, okay? This is how you're done. Okay, so what else? So we have written our first Go code. Now we are ready to move on to multivariable functions. So is there any questions? No, there is no lecture note. The question is there a lecture note uploaded after class? I did have a lecture note, or slides last semester or last year. That's when I gave a lecture through slides. But here in this semester, I'm going to give mainly a Blackboard lecture. So there will be no class material uploaded in the LMS. Okay. So let's talk about multivariable functions. So usually we begin with vector, and sometimes multivariable function is called the vector multivariable calculus is called the vector calculus. We have to understand why we need vector to understand the multivariable function. So in order to do that, I'm going to ask questions. So before we actually start the first lecture of the semester, let me mention a few things. So first, basically, I'm going to ask questions in lectures and brief answer. I'm not going to write the answers in full sentences or give a full, nicely written lecture handwriting lectures. But I'm going to write our questions in complete sentences and make another questions until the questions make sense to you. And second, just consider this lecture as a story, the old story that comes from hundreds of years ago. Okay? This is a story that frames your own story. So your own story is your own project. That's the real content. Your project is the real one. What I'm telling you is the story that you have to fit in. Okay? So I'm going to talk about the functions and differentiations, all other mathematical terms. You have to fit your story in terms of those mathematical terms or mathematical settings. So don't dive into this story too much. Okay? So this is just a story that passes through, and as long as you understand with your own concepts or own understanding, that's fine. You don't have to go deeply into, if you want to, you can, but you don't have to go into deeply how to prove this theorem or how to apply this theorem into this weird formula and so on. Okay, that's the few things that I want to mention. Okay, so first question, what is vector? So a few years ago, I didn't have to ask this question because high school students already learn about the vectors in high school. But now high school doesn't teach the vector anymore, so I have to define it. So I'm going to tell you that there are several versions of definition of vectors, but the easiest one is the following. You have n tuple of real numbers is called n-dimensional vector, and these are real numbers. So if I finish my answer here, you might have a questions. What is the difference between vector and just tuple of numbers? Because there's actually no difference. I said the n-dimensional vector is just a collection of different n numbers in orders. It's just the n tuple of numbers. So this not complete answer. You may already guessed. So we need a few more properties of vectors. So first, if you have two vectors, you can add them together. So how you add two vectors is adding component-wise of these values. A1 plus B1 is the first component, and so on, and AN plus BN is the last component. So once you add these two vectors, you get a new vector. Okay? And second, you can multiply your vector with some number. So let's say we have C, a real number, and you can multiply C with a vector A1 to AN. How you multiply is using the distributive law, and C times A1 is the first component, and C times AN is the last component. So you already, again, you get a new vector here. So this is the intuitive, the most easiest way to define a vector. So and then you have another questions. As I already mentioned before, what is the other way of defining vectors? What is the abstract way of defining vectors? If you want to, I can tell you, but that's your own task to find out the answer. So I will give you a hint that the set of functions can be of vectors. The functions can also be a vector. Okay, for example, his question is there another type of vectors? Not just n tuple. Can I call another mathematical object as a vectors? Yes, you can, because let's say we have V as a set of function defined on 0, 1 to real number. Doesn't matter. I don't give any properties on F. So V is function. The V is a set of single variable functions that we already know from the previous semester. That it's a function defined on the interval from 0 to 1, closed interval to real number. So any element in this set is a vector. It's a set of vectors. It's a function, but it can serve as a vector. Find out why it happens. Why it makes sense. So there are abstract definition of vector space and vectors. You can Google it and find easily what that is. All right. So let's think about what can we do with the vectors? Why or what or why? It basically can be the same questions. Why do we need vectors? It's too general, right? Vectors are used in many places. So let me be more specific. Why do we need vectors in multivariable calculus? So, for example, let's think about the most general form of multivariable functions. I already gave you the simplest and easiest form of multivariable function before. but let me choose to be the most general, let me choose the most general form of multivariable function as the following. So we have x1 to xn as an independent variable of this function f, and y1 to ym as a dependent variable of this function. So if I write this way, it means that y1 up to ym is the function depend on this n variable from x1 to xn, and it has n independent variable and m dependent variable. So if you don't care about additive properties and scalar multiplicity of vectors, then these n tuples and m tuples can be considered as the form of vectors, right? So these are m tuples. These are m tuple. You can consider this as vector and vector. Let's say this is called V, and this is called W. So I can rewrite this as f of V. Let me put it vector notation here. So the arrow above symbol means that it's considered as a vector. So basically, I can rewrite my multivariable function as a function sending a vector to another vector. So the dimension of these two vectors are different, but these are just a vector. So these vectors are, again, becomes an independent variable and dependent variable of multivariable functions. So if you just replace your dependent variable and independent variable in single variable function using these vectors, it becomes a multivariable function. So this is the general form of single variable function. You replace these values with vectors, then it becomes a multivariable function. So vector is the building block of multivariable function. Of course, there are other reasons and lots of reasons why we need the vectors. But in order to explain that, we need pre-knowledge. So this is as far as I can explain about these questions. But let me mention one more thing. We need vectors to graph the multivariable function. So that's the content that we're going to cover next lecture, but let me briefly explain what that means. So whenever you want to understand a function, you need either formula or the table of values or a description of functions, or the last one is the graph of functions. The graph of function gives the intuitive description of this function, how these values are dependent on other values. But in the single variable function case, we draw this function in the two-dimensional plane. So x is independent variable. It represents the horizontal line, and y is a dependent variable, and the single variable function looks like, the graph of single variable function looks like this. Now, in the two variable functions, this is called a two variable function. You usually don't call this as a two variable function. We have another name for this type of functions. It's called a parametric function. So I'm talking about this kind of function. We have three variables to draw in the space. So x and y determines z. So I need to take this x and y moves independently, and then z is dependent to these two variables. Then I have to graph it on three-dimensional space. So how it's drawn is that for every value of independent variables, let's say x0 and y0, this function has a formula, for example, z equals x squared plus y squared. So there is a z0. In this case, for example, x0 squared, y0 squared, determined by this formula. And I need to plot this point, and I have to do this for entire x0 and y0 on this x and y plane. And then put it all together, it becomes the graph of functions. So how can we draw this graph? So you see this picture looks like three-dimensional thing because we're using our intuition in human mind. But it is not actually three-dimensional picture. It's a two-dimensional picture. It looks like three-dimensional, two-dimensional. So in order to graph this kind of picture, we need to use the vectors. Okay. Okay, so one more thing about the vectors. Let me mention about the inner product. The question is, so if I don't know about the inner product, I can ask a question about the inner product. So my question is, you have a vectors, you have an n tuple of numbers as a definition of vectors. Now, how do we use vector as a geometrical object? Because if you have a two-dimensional vector, for example, it's just not, it's a pair of points, right? So you can consider first coordinate as an x coordinate and second coordinate as a y coordinate. And this two-dimensional vector only represents the point, okay? You can consider that as an arrow starting from the origin to the point having the same coordinate as vector coordinates. Okay, here, A1 and A2. So this point has the same coordinate as the vector coordinate, phi A1 and A2. So this kind of vector is called the position vector. It just simply tells you the position of this point. Now, it obviously says that vector has some geometrical properties because it gives you the geometric position of a point. Then how do we consider these vectors, any random vectors or pair vectors geometrically? So if you simply have random vectors, you don't know how these vectors are distributed. If you know their coordinates, of course, then you can draw it. But just say you have a random vectors and you don't know the coordinates, but you have some relationship between other vectors, then you probably find out the position of these vectors. So that's where the inner product comes in. So we need the inner product. So how do we define inner product? Let me define the general way of defining inner product, and then be more. Let me define the inner product on n-dimensional vectors, and then move on to the general inner product. So we have two n-dimensional vectors. So the symbol for inner product are usually written as the bracket here, what is it called? Pointy bracket here. And sometimes people write it in this dot, the empty dot symbol. And it is defined to be the sum of products on each coordinates. For example, A1 is multiplied with B1 and added to A2 multiplied with B2, and so on up to AN multiplied with BN. Okay? So that's the inner product. So I know the definition of inner product, that's how I explained it, but you have to understand why people come up with this formula and why it's important. So there's the properties of inner product. Let's say we have vector, two vectors, and you take the inner product together. I used the empty dot notation of inner product here. So I can, throughout the semester, sometimes I will use this pointy bracket or sometimes use the empty circle. So this is same as these values. So I have to explain what these are. So we have a vector in between these bars. Two vectors are in between these bars. So this means that it's the norm of V. So the norm means that it's a square root of inner product of V itself. Okay. Same for the W norm. And what is the theta here? Theta is the angle between V and W. So for example, in this picture, two-dimensional vectors have angle theta. So we have this property. We will prove this, but before we prove this, let's consider the consequence of these properties. What if these two vectors are perpendicular? What if these two vectors have angle, angle between these two vectors are pi over 2? Then cosine pi over 2 is 0, so the inner product becomes 0. In other words, as long as V and W does not have 0 norms, only way we can have a 0 inner product is when the theta is pi over 2, which means that these two vectors are perpendicular. So we have property that two vectors are perpendicular if and only if inner products are 0. And not only for the perpendicularness, we can find out the angle between two vectors using the inner product. Without actually drawing these vectors into planes, we can find out the angle between these two vectors using these algebraic equations defined for inner product. So that's good about the inner product. That's how we use the inner product as the geometric to find out the geometric position of the vectors. Before we move on to the proof of that theorem, properties, we should have a question. at this moment. But I will give you a chance you to ask a question now. My hint is you should have a question on the definition of theta here. I'm guessing that you're thinking about the questions. By the way, if you asked any questions and if you think that is a good question, you can put that into your page in the question section. And you can also put the answer based on my answer. Okay. Because this is the first day of class, I will give you the chance to make your own questions based on the lecture. So I'm giving a hint that I mentioned that this theta is the angle between the two vectors. You should have questions at this point. What do you mean by angle between two vectors? Some might ask, or some might answer, but that's obvious because this is here. So the angle is here. But if you think a little bit further, this picture is only for two-dimensional vectors. In general, the vector can be n-dimensional. For example, the vector could be three-dimensional. How do you measure angle between two three-dimensional vectors? That's my question. Or the question that you probably was going to ask. How to measure. Well, let me say, there could be a lot of ways of measuring, just measuring, but what I really want to ask here is, what is the theta when V and W are n-dimensional? Here n is bigger than 3, is bigger than or equal to 3. So what do you think? So then the answer should involve how to measure such angle, right? So the question is, what is or how do you define such theta in higher dimensional vectors? And answer should involve how to measure such angle. How can you measure the such theta in higher dimension? Yes, you can use the inner product and norm. So inner product is defined for any n-dimensional vectors. It's n sum of n sum n's of these numbers. And norm also well defined because these two are n-dimensional vectors. We have inner product between n-dimensional vectors. Whenever you take the inner product between same vectors, then you always have a positive number because all the sum n's are squares. So you can take the square root. So norms are well defined. So only thing you have to be clear is what's zeta in this case. Okay, so there's a two remark here. For first one, I will I will prove that equality. This is not definition. This is the equation that needs some proof. I will prove this. But before, to make sense what this equation means, I ask what zeta is. Second remark is that you can define as inner product divided by two norms and take an arc cosine. That makes sense. That makes sense, but what I meant by this question is if you know the norm, if you know how to find out the inner product and norm, you can find out zeta. But sometimes you have no information about the inner product, but just the norm and the zeta itself. Then you can reconstruct your inner product from this information. So then you need to find out how to measure the zeta from the geometric point of view instead of this inner product. So I want to express this way of measuring zeta without using the inner product. Think about it a little bit more. I think it's an interesting question. So I will give you plenty of time to think about and then opportunity to express your answer. The question is, where is the recording of the lecture coming up? It will be on my YouTube channel. That's the link is on the LMS site. I forgot to put it on the email notice. I put it in the LMS notice. So go to the LMS website and then our course page has a notice and there is a YouTube page. Okay, so think about that question. Let's prove this. Now, I will going to prove that in two-dimensional case. All right, so here we have V as A1 and A2. Now, I have a different way of measuring this A1 and A2, which is polar coordinates. So we have R1 and length and theta 1. Okay, and then W, this is V. And let's say W has length R2 and angle is theta 2. So whenever I said I take the angle, I'm taking a counterclockwise orientation as the positive side. So I'm taking theta 1 measured from the positive x-axis counterclockwise, so it's gonna be a positive value. And this W is measured from the positive x-axis to clockwise orientation, so this theta 2 is a negative value. So whichever value that is, I can express that as polar coordinates, so it's R1 1 cosine theta 1 and R2 sine theta 2, sine theta 1. And W, let's say B1 and B2 is given as R2 cosine theta 2, R2 sine theta 2. Let's take the inner product using that definition. The left-hand side is defined to be the sum of products here. So we have R1, R2, cosine theta 1, cosine theta 2. And here R1 and R2, sine theta 1 and sine theta 2. So R1, R2 are common vectors. And we have cosine theta 1, cosine theta 2, sine plus sine theta 1 and sine theta 2. We have a formula for cosine and sine, and it becomes cosine of theta 1 minus theta 2. So cosine is even function. It doesn't matter whether I put theta 2 minus theta 1 or theta 1 minus theta 2. Whatever that is, it's an angle between these two vectors. You see, theta 1 minus theta 2 is theta 1 plus this angle, because theta 2 is negative, measured negative here. So this is going to be the cosine theta, the angle between two vectors, times gamma R1 and R2. So R1 is the length of V. When you take the norm of V, what you get is the square root of sum of squares of each coordinates of vectors. That's the length of the vectors, right? It's the Pythagoras formula, Pythagorean equation. So we have V norm as R1 and W norm as R2. So that's the proof. That's the proof for the two-dimensional vectors. So if you want to think about the proof of higher dimensional vectors, you have to think about what that theta means. You have to think about, you have to be able to answer that question. All right. Any other questions? There was a few other remarks here. Oh, okay. Okay, that's all. If you come up with any questions, please let me know anytime. So meanwhile, I want to tell you how to write your Go code. So I already did in a Replit, but Replit is cheating. So it's not really good when you have a complicated code, because Replit doesn't provide auto complication and the suggestions. So this is a Visual Studio Code. When you install and then run it first time, you will get this kind of page, and press open file. I'm sorry, not open folder. Sorry. So open folder, and let's say let me make a new folder. Here we have multivariable calculus. And then I'm going to select that folder as my project folder. I trust the author. So, so this pops up because I installed the GitHub, which is the Git. So I will trust everything because I am the writer. And let's start with new file. So since they have no the suffix, it says select the language, but let's say let's write a new file here. So I will make a file name as main.go. So then this VS Code recognize this as a Go programming code. And also, before you actually begin anything, I recommend you to install extensions. So in the left-hand side, there's a menu, and one of them is extension. If you click this, it shows the pre-installed extensions. You probably have no extension in the beginning, but I installed these before. I used VIM, which is the, I don't recommend you to install this. Don't install this. This is just the person who are familiar with Vim, then it's very helpful, but don't install this. But you have to install Go. So Go extension gives you lots of suggestions and auto completions. So you have to must install this Go. And anything else is not really important. So just you can search for extension name and then Go. You can just install this here. Yeah, I already installed, so it says uninstall. But if you didn't install it, you will have install here. Okay, so go back to the main.go. So let's write our package. So I'm going to make it a main package. So I will explain why name matters later, but for now, we'll only work with the main. And I'm going to make a main function. So main function has no input argument. So this is a basic rule that you have to follow whenever you write main function. So let's basically write the same thing here. So print ln. So it means a print line, and I want to write hello Go. Okay. That's it. But now we have a red line underneath this FMT. So if you move your cursor over it, it says undeclared name FMT. So fmt.println means that I'm going to use println function from fmt package, or it could be fmt structure or something else. However, I haven't declared what FMT yet. Now, so if you keep viewing it, let's see view problem, you can click view problems. You can see clearly what the problem is. So I already mentioned that this FMT is a pre-installed and provided package of Go, so you have to import that. Then you don't have any problem here. So now the red line disappeared here. Now this is final. You have to run this code or build this code. So here, let's see. Go to view and let's see. Press terminal. Okay. So then you have all four different tabs here: problems and output, terminal, debug. So usually if you run this code using the program menu, start debugging, or run without debugging, then the output will appear in the output tab. But I prefer to run this in terminal. So terminal is just the console command. Here we have a multivariable calculus pulled folder, and I'm using go run main.go. Then this Go compiler actually compiles this Go code, and the executable file is temporarily stored in the hidden folder, and then it runs this executable folder. However, you don't have executable file appears in your folder. But if you want your executable file, then you can use the Go Build menu, but you see there's an error message. It says you don't have a go.mod file to find in current directory or any parent directory. It means that you need initialize your Go mode. So Go mode init says that example usage is the following. So you need to provide a name of this package. So I'm going to use Go mode init, and usually it goes with the GitHub page names, but you don't probably have, most of you guys have no GitHub page, so I'm going to go with the multivariable name. Okay, so name can be anything, but usually go with the GitHub site name. So and then Go build. The reason why it takes so long is because I'm running the streaming program and recording at the same time, and also running a Zoom. So, but it should finish in no time. So anyway, so once I made the Go mode, there is a Go mode file, and it defines the name of this module is the multivariable, and it uses the version of Go 1.16. And when I put a Go build, then it makes creates multivariable.exe. Multivariable comes from the name of this module. So the concept of module could be a little bit confusing for it at this time, so I'm not going to explain that. So anyway, you can just consider this whole project is named multivariable, so that's why it has a multivariable.exe. So I can run this multivariable.exe here, and here is our output, hello.go. So basically, if you're just working with the main.go and FMT package, then you can simply print strings and so on. But I will show you how to use the drawing tools that Go provides the next time. So here we have almost, the class times is almost over. So this is how you basically run your Go code. So class will operate in similar format from now on. We will have a few moments to go through your assignments, and then, what I mean by assignment is that I will present some of the good examples of completing assignments of some students, and then give some lectures, and then move on to the Go programming parts, and then that's the end of the class. So if you come to class offline in the classroom, then you can ask questions more freely, but it's okay not to come, especially when you're sick. I know that you're all quarantined these days, so and ends on Thursday. So I hope many people can come on Friday class this week. So if you have any question before I finish, I can answer briefly. If not, we will call it here.